Alright, welcome back. Let's look at the back side of 214. Basically we're starting off with some pretty basic, we're just reducing radicals. Again, the first one's square root of 25, we know that's 5. Here, if I take this radical and break it down into two parts, it's going to be, I want one of the factors to be a perfect square. So in this case I can go 9 times 3, and then I take the square root of 9 and I get 3. That comes out. This 3 stays under the radical, and then I get this. If you move on to number 3, you can see this one, it's not a perfect square. However, I can break it down to 4 times 10, and now when I take the square root of 4 I get 2. That goes on the outside and the 10 stays underneath. You've got to make sure, it's kind of like finding the greatest common factor. You want to find the biggest perfect square that goes into both of them. For example, when I look at 72, 9 times 8 does equal 72. But the thing is, so does 36. So what you want to do is take a look at the number and start with the perfect squares that go below it. 72 doesn't divide evenly by 64. It doesn't divide evenly by 49. It doesn't divide by 36, but yes it does. So 36 is 2 times 36. So then what happens is that we take the square root of 36 and we get 6. That comes out and the 2 stays underneath. Now, take a look here. Below, what's happening is we're combining these. We've got square root of 99, x squared, y to the third. You get 9's here, right? So let's try this. I mean, again, like I said before, it doesn't divide by 81, doesn't divide by 64, it doesn't divide by 49, doesn't divide by 36. Keep on going down, you'll get down to 9. So let's try breaking this apart. 9 times 11. Now x squared is a perfect square. Y to the third is not, but y squared is, and if I multiply y squared times y, I still have y to the third. So now I've got everything pulled apart, and all I've got to do is take the square root of the perfect square. So square root of 9 is 3. That's coming out. I can't do this one, but I can do the square root of x squared. That's x. That comes out. The square root of y squared is y. That comes out. And that leaves me with 11y left underneath. Here, if you take a look at the next one here, we've got 160, and I can break this apart into 16 times 10, x squared times x, and then y. Once again, x squared times x is the same thing as x to the third, but now I've got a perfect square. So the square root of 16 is 4. This comes out. 10 I got to leave in there. X squared, square root of x squared is x. And then these two guys stay with the 10. So I've got 10x, y. Now, the next set, basically what we're doing is we're adding and subtracting. And again, keep in mind, this is a lot like combining like terms. So all you've got to do is keep in mind that you only can combine the things or the terms that have the same square root under the radical. There's nothing else that has a square root of 3, so this is not going to change. These guys are the same radical, and so what happens is the only number is going to change is going to be the one out front. So it's going to be 9 minus 4, or positive 5 square root of 2. Take a look at here, the second one. These two go together, so it'll be 2 minus 4, or negative 2 square root of 3, and then plus 4 square root of 5. Alright, now when you look at number 10, what's happening is that we've got to reduce these. These are going to be all fractions in this row. So what we're looking for is either a fraction that I can reduce, or one of the numbers or both numbers being perfect squares. If you take a look here, the 16 is a perfect square. So let's go ahead and do this. I'm going to do square root of 16 over square root of 5. Now that makes it so I can do this. Square root of 16 is 4. Now that doesn't help me much with the bottom. So now the only way I can get rid of the radical out of the denominator is to multiply both the numerator and the denominator by square root of 5. When I do that, I end up with 4 times square root of 5, or 4 square root of 5. And then this is going to be 5 times 5, or square root of 25. The square root of 25 is going to be 5. And so now I've gotten rid of the radical. Now the top stays where it is. I take one quick double check and make sure these don't reduce. They don't. So I'm good there. Here in this one I'm going to do the same thing. I have to get rid of the radical at the bottom. But I take a look here and I do know what 10 divided by 5 is. So I can go and fix this. I'm going to make it like this. 2 times the square root of 10 over 5. So then what is 10 divided by 5? Well, it's 2. And so I end up with 2 square root of 2. This one, we're going to multiply both of them, the top and the bottom, by square root of 6. And so we end up with 8 square root of 6 over square root of 36. This gives me 6 on the bottom, and then quickly I notice that these two still will reduce, so I divide both the top and the bottom by 2, and I get 4 thirds, and that's that. Now, if you look at number 16, what's happening is these are just like the ones in 1, 2, 3, 4, and 5. I'm not going to do them again, but 64, square root of 64, that's going to be 8. This is going to be x squared, and then this is going to break apart to y squared and y. So let's stick it down here at e. In e, what happens is that I've got these, and they want me to change it into exponential form. And so the way I change this to exponential form is I want you to keep in mind that this is a square root, but that means that there's a little 2 down there. And so all I've got to do is that remember what this power is, and then write the fraction. It'll be x to the 1/2. So there's that. So then when I write this one, if I want to write it in exponential form, I write the z, and it'll be to the 2/5. And it goes on like that. And one more will do. If you take a look at number 3, it'll be y to the 5/3. The root is always going to be in the bottom, and the power of whatever you're doing under here is going to always be on the top. Now, if they want to go the other direction, what we want to do is take these guys and switch them back to radical form. And so the way we do this is just the opposite of what we just did a second ago. What we're going to do is that write the radical. The bottom of the fraction is going to be the root, so it'll be a cube root, and it'll be x to the 5th. Here, again, I'm writing it in radical form, so there's my y. It's a square root, so I can put the 2 there or not, because whenever there's nothing there, we assume it's a square root. And then it'll be to the 7th power. And then here, number 3, I've got, again, writing it in the radical form, so we'll put the z there. This bottom part of the fraction tells me what the root is. We're finding the 5th root. And then it tells me, the top number tells me what the power is going to be, and that's going to be 3. One more. Number 4 is going to be radical x. I look here, the 3 tells me what the root is. I'm finding the cube root. Now remind you, these aren't coefficients. I'm not putting this, it's not 3 times this. This tells me what kind of root I'm doing. So I'm finding the 5th root, I'm finding the 3rd root. And then here, this is going to be 2. And so all I'm doing is rewriting these in a different way. Here, I'm taking the radicals and writing them as fractions, or I'm writing them with the exponential, fractions. They're called rational. And then these, I have a rational exponent, and I'm changing and putting them in radical form. All right? Hope you've had a great week. I'll talk to you again soon. Bye.